let's decode the value for 3 logarithm of 4 base to the base 2 without using any calculators. So for this, we are going to predict or assume the value. So for this, we are going to get the value using properties and important rules according to the logarithm or logarithmic equations probably later in order for us to get the entire value. If we are going to equate the entire expression to x, let's say a variable x, then we can have a logarithmic equation. And whenever we have a logarithmic equation, we can transform it into an equivalent exponential equation using this manner. For any logarithmic equation with logarithm of a to the base b, which is equal to any value of x, we can transform it into an equivalent exponential equation using b, the base, and this would be your exponent x is equal to a. And since again are given, we assume because that's what we would like to decode. In short, we are looking for the entire value represented by x. We can transform it into an equivalent exponential equation. But there are three methods here. There are two methods that I could share to you, and it's up to you which method you will use later. I'm going to discuss both of them. The first method is when we are going to solve for this first, the logarithm of 4 with the base 2. And let's say this is what is x, okay? Or yeah, let's just use y for this so that we can differentiate this with the actual value later. So if this is the representation for the part of the entire unknown, we could transform this into equivalent exponential equation. We have 2 to the power of y is equal to 4. Okay? And we are going to apply here the property of equivalent exponents because what we are looking for is the value of y as an exponent. The property of equivalent exponents tells us that if we have two exponentiations of the same base and they're equal to one another just like this, x to the power of m and x to the power of n, the bases are the same, we can say that the value of the exponents are also the same. We're talking about this because 4 can be expressed as 2 squared. And since our left hand side also has a base of 2, so since they are of the same, we can say that the value of y is equal to as 2. Yeah, that's the exponent. The value of the entire y, the value of variable y is equal to 2. This would mean this value here is the entire value of this portion of the unknown. And if we are looking for 3 logarithm of 4 to the base 2, and since the value of logarithm 4 to the base 2 is as y, and that's equal to 2, in short, the entire value of the given is 3 times 2, and that is 6. So we were able to solve for the first method that I am sharing to you. We're able to solve the value of a portion of the unknown, yes, and the entire expression using the property of equivalent exponents and this. The second process is by the application of one of the theorems pertaining to the logarithms, logarithmic equations as well. So you have here this form, right? If we have this form, this value here, the coefficient of the logarithm can be placed as the exponent of this coefficient. So you will have here the logarithm of let's say 4 cubed to the base 2, which would actually be equal to the logarithm, or we can just hold with it. Let's hold with that value, because if we have this expression, this exponent, and we are going to equate this to x as the entire expression as mentioned earlier, we can apply here the property again or transformation to an equivalent exponential equation. You will have 2 to the power of x is equal to 4 cubed. And using the property of equivalent exponents, we can also express 4 as a base 2. So you will have this 2 squared, and then we have here cube, which will ultimately allow us to apply this the power law of exponents here. So 2 to the power of x is equal to 2 to the power of 6. That's 2 times 3 is 6. And the property of equivalent exponents tells us that we can just simply drop the base and say that the exponents are just the same. And as mentioned, we have the same results as the first operation earlier. The first operation only solve a portion of the unknown before solving the entirety. But the second process will apply one of the theorems that will allow the coefficient to become exponent of the value here, and still applying the property of equivalent exponents, you will get the same results. So we have decoded that the unknown, the 3 logarithm of 4 to the base 2 is equal to 6. And this is mission accomplished.